Let's do an example of finding the radius of convergence of a power series. Now, I've got a power series. As an example, this one is n equals 2 to infinity, x to the 2n minus 1 over 2n minus 1 factorial. Now, you could change the starting point of this anytime you want. We're not going to do that. We're just going to find the radius of convergence. So I'm going to treat this a little bit loosely. But here's what we're going to do. We're going to use the ratio test. So ratio test. And we're going to find out if this series converges, and if so, where. So we've got the ratio test is the limit as the n values go to infinity. We've got to take the next term after this one. So it's x to the 2 times n plus 1 minus 1 over 2 times n plus 1 minus 1 all factorial. Watch out for those factorials. And then I'm going to divide by the original, which is multiplying by the reciprocal. So 2n minus 1 factorial, that's this one. And then down here we've got x to the 2n minus 1. Absolute value of that limit has got to be less than 1 in order for the ratio test to show that it converges. So I need to simplify this out just a bit. I'm going to take n goes to infinity. I've got x to the 2n plus 2 minus 1. That's actually just 2n plus 1. Here I've got 2n plus 2 minus 1. So 2n plus 2 minus 1 is actually 2n plus 1. I'll cut that one short. Here we've got 2n minus 1 factorial, and this is x to the 2n minus 1. It's less than 1. So I've got some more simplifying to do. X to the 2n plus 1 versus x to the 2n minus 1. Algebra tells us we need to subtract exponents. So let's do that. This is the limit as n approaches infinity. X to the 2n plus 1 over x to the 2n minus 1. That's going to give us x to the 2n plus 1 minus 2n minus 1. Okay, 2n minus 2n is 0. 1 minus minus 1 is 2. So that's just x squared. Here we've got 2n plus 1 factorial versus here we've got 2n minus 1 factorial. Let me do a little work on that. This is 2n plus 1 times 2n times 2n minus 1 factorial. This is 2n minus 1 factorial. So this stuff's got to be less than 1. So here's what we've got at this stage. We've got this and this, which can cancel. We've got to take the limit as n goes to infinity of x squared divided by 2n plus 1 times 2n. Now that limit, I'm not putting the less than 1 at the moment, but that limit as n gets bigger and bigger and bigger is equal to 0. Okay? Now 0 is less than 1 all the time. So consequently, this function is going to converge all the time. So this converges for all real numbers. These are easier if you can get something that will converge for all real numbers because you don't have to check endpoints. There are no endpoints. So there you go. Let's try one more example. I want to take the sum. N goes from 0 to infinity of x over 3 to the n. Now you might look at that and say, well, okay, I need the radius of convergence. We need to use the ratio test. Well, we could do that, absolutely. But this one's kind of nice because you might recognize this series. This is a geometric series. So this is one of the few times when we're finding radius of convergence when we really don't have to use the ratio test. AR to the n goes from 0 to infinity. So if you remember from the geometric series, if this is AR to the n, and n goes from 0 to infinity, then as long as the absolute value of r is less than 1, then this thing's going to converge. So what's going to happen? We've got to have x over 3, that's our r value, is less than 1, so it'll converge. That is minus 1 less than x over 3 less than 1. Multiply through by 3, you get negative 3 less than x less than 3. So our radius of convergence is half this distance, so the radius is equal to 3. The center is the middle, so that's equal to 0. And our interval of convergence is minus 3 to 3. Now we've got to check the endpoints on this one. So if you put negative 3 in, you're going to get this series. N equals 0 to infinity, minus 1 over, or minus 3, minus 3 over 3 to the n. Well, that is just n equals 0 to infinity, minus 1 to the n. That's minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, on and on, so that diverges. That is an alternating series. It doesn't go to infinity, but it just never has a set value. You could add them forever and they just keep bouncing around. The other one is, what if you go n equals 0 to infinity and you use the other endpoint? You've got 3 over 3 to the n. That is the same thing as adding 1 an infinite number of times, and 1 plus 1 plus 1 plus 1 forever also diverges. So your interval on this one is minus 3 to plus 3, does not include the endpoints. Radius is 3, center is 0. Okay.